Okay, so I'm going to do the first 10 or so problems in this segment. First, let's look at this problem. We see that anytime you have a trig function with the exponent right here, I want you to rewrite the problem. Okay, if you have a number in front, that's not included in the parentheses. So it's going to be 3 and then parentheses secant of 2x to the fifth. Now this is a peanut M&M. You have the shell being the fifth, the chocolate is the secant, and the peanut is the 2x. So when I go to take the derivative, you do the outside first. So the derivative f prime of x is going to be, let the shell melt, 5 times 3 gives us 15. You lower the power by 1, so you have 4. Do not chew the chocolate, guys. No chewing of the chocolate. And don't change the peanut. The peanut is 2x, so it's going to be 2x here. Now 0 in. Now you're in this part here. You're going layer by layer. The next layer is the chocolate that melts. What's the derivative of secant? It's secant tangent. Now, do not change the peanut. It's still 2x and 2x. Now here in your original problem, you see you have a 2x layer, a secant layer, and a fifth layer. We've done the fifth, the secant, and now the 2x. What's the derivative of 2x? It's 2. So, looking at this, I just want you to look at things that are algebraic and multiply them together. So you have the 15 and the 2, so that's 30. And then you have 4 secant of 2x's here and 1 here, so you have 5 of them together. So here is our answer to number 1. Now let's look at number 2. Number 2 is just a simple plain M&M. We have the cotangent on the outside, 4x plus 1 on the inside. So derivative of cotangent in general is negative, all the c's change the signs, cosecant squared. So if I'm going to change the sign, instead of a negative 3, it's going to be a positive 3 cosecant squared. Do not chew the chocolate, so it's still 4x plus 1. But then let the chocolate melt. Don't forget to let it melt, times the derivative of the inside, which is 4. Now I combine the algebraic things. 3 times 4 gives us our 12 cosecant squared of 4x plus 1. So here is our derivative. Okay, number 3. Anytime you see a root, rewrite. Okay, so g of x is going to be equal to 3x minus 2 to the 1/2. Notice I did not say g prime because I haven't taken the derivative yet. Anytime you have something in the parentheses, it's a chain rule problem. So let the shell melt first. 1/2, and then you bring down negative 1/2. Do not chew the chocolate. Let the chocolate melt, multiplied by 3. Now you can multiply the algebra things together. 1/2 and 3 gives us 3/2. So you can keep the answer exactly like this. This is full credit, or you can write 3 over 2, 3x minus 2 to the 1/2, or you could even write 3 over 2, the square root of 3x minus 2. Any of these are full credit. Okay, this problem is simply a plain M&M. You have tangent. Derivative of tangent is secant squared, so it's going to be 5 secant squared. Don't chew the chocolate. 3x squared plus 1 times the derivative of what's inside, 6x. So multiply. You have your 5 and your 6x. So you have 30x secant squared, 3x squared plus 1 as your derivative. Okay, this is, again, a plain M&M. This time your outer function is sine. The derivative of sine is cosine. It's the same sign if you're taking the derivative of sine. Don't change the chocolate. Now let the chocolate melt. 3x squared is the derivative of x cubed. Again, when you have algebra and trig, make sure you put the algebra in front of your trig in your final answer. So this is h prime of x. Okay, this one is also a chain rule problem, but this time, remember, anytime you see this kind of trig function, I want you to write it in parentheses like this. So this time it's the opposite of the previous example. My outer function is the cubed. So when you take the derivative, It's 3, and you bring this power down by 1. Do not chew the chocolate, so it's sine x. Now let the chocolate melt, so it'll be cosine x. So you can leave it like this if you want, or you can write 3 sine squared x, cosine x, like they do in most calculus books. Okay, number 7, you have to use the quotient rule. I know you have to use the quotient rule anytime you have multiple terms on the bottom, okay? If this was reversed, if it was x squared plus 4 over x, then you could separate this out like this, and you wouldn't have to use the quotient rule. You would take the derivative from here. But in this case, you're not allowed to separate it. So we're going to say, oops, let me give it my color. The derivative of the top is 1 times the bottom minus the derivative of the bottom times the top all over the bottom squared. Now I'm not going to make you square out the bottom. Be careful too. Do not cross these out. You can't do it because this factor has to be here and here. You have to be able to do I, heart, math to do that. So simplify by multiplying out. So you get x squared plus 4 minus 2x squared all over x squared plus 4 quantity squared. So you get 4 minus, if you combine these two, x minus 2x squared, you get a minus x squared. And this is where you end it. Okay, you have to rewrite this. This one, you have a 1/2 power, you have a tangent, and you have a 4x. So it's a peanut M&M, my favorite. Okay, so you're going to take the derivative by bringing down the 1/2 first. Subtract 1, so you get negative 1/2. No chewing the chocolate. It's tan of 4x. Don't change anything about the inside. Now layer by layer. The next layer is the dark layer, the tan. What's the derivative of tan? Secant squared. Again, one thing at a time, so that 4x stays the same. Now the derivative of the peanut is 4. So multiply your 1/2 times your 4. So that would give you 2. And then you can keep it like this, or you can write secant squared of 4x over tangent of 4x to the 1/2, since that's a negative 1/2. Or you could even write 2 secant squared of 4x over the square root of tangent of 4x. Either of these. Okay, we have to use the product rule. You always look for product rule, quotient rule, all those things first. So you'll do the chain rule within that. Product rule, don't forget plus. Anytime you have a product, you have to do a plus. Derivative of the first, 3x squared, times the second. Now look, I'm just multiplying times the second function. Just g. If this was my g and this was my f, you're not taking the derivative of g here. You're just writing down the function, so you don't need to worry about the chain rule for this part. But now when you go to take the derivative of cosine of something, that's your outer shell, is sine of that same thing, but then because of the chain rule, there's something here other than just x. Multiply by the derivative of that, which is 2. So this is the derivative of your second thing. Then you have to multiply by your first thing. So we have the derivative of the first times the second plus the derivative of the second times the first. So this is 3x squared cosine of 2x plus, write the algebra in front, 2x cubed sine of 2x. Okay, we gotta do the quotient rule here. So it's gonna be the derivative of the top, 2 times the bottom, minus the derivative of the bottom, 1 times the top, all over the bottom squared. So if I simplify this out, multiply things, so you have 2x plus 6 minus 2x minus, plus 1, all over x plus 3 squared. Don't worry about the bottom. 2 x's cancel, so you're left with 7 over x plus 3 squared. I'll continue on in the next section.